Okay, so hi everyone. Once again, a very warm welcome to the webinar, Future of the Biomedical Industry with AI. I'm Wansin from SGTech, and I'll be taking you through today's webinar. So we're so glad to put together this topic as the COVID-19 pandemic eases, as it remains critical for organizations to digitalize, especially in the current economic climate. Right, this webinar is proudly brought to you by SGTech's Artificial Intelligence and High Performance Computing chapter, AI and HPC in short, with the support of AI Singapore, NUS, and Nvidia. So just some quick housekeeping before we commence the program proper. This session will be recorded for archival and marketing purposes. SGTech may also use some of the images or videos that we capture in our publications, digital platforms, or marketing channels, right? The slides and recording will also be made available post-webinar on SGTech's website. And I would like to strongly encourage that all participants send in any questions that you have to our speakers via the Q&A feature at the bottom of the browser. So today we have an amazing lineup of speakers to shed light on how the biomedical industry will evolve with AI. As you can see here, we have a very holistic agenda covering perspectives from across AI Singapore as well as academia and the industry. So without further ado, I would like to invite Mr. Richard Koh, Chairman for AI and HPC chapter, to address the audience. Richard, over to you, please.
Okay. Thank you, Wansin, and good afternoon to everyone. So wherever you are joining this webinar from, whether is it at home or in the office or maybe in a park somewhere, I hope you are keeping safe and keeping well. And thanks for taking the time to join us on this very exciting topic, and obviously a very topical topic in this unprecedented times of the COVID-19 pandemic itself. So as the technology industry and landscape continues to evolve, SGTech definitely plays a very important role here in Singapore in developing and also advancing initiatives that to help businesses in their digitalization efforts and their digital transformation journey itself, and also the community at large. And our members ranges from startups, small and medium businesses, as well as large multinational companies who are based here in Singapore. So I think a lot of times people think about SGTech as being just being a members base of tech companies. This is not true. We have expanded our membership base to all companies, because I think firmly we believe that all the companies today are leveraging technology in one way or another, or they cease to become relevant into the future. So I think this is an important aspect as we think about our membership base and really expanding that to be able to help the different companies on their digital transformation journey itself. Now, there are 6 chapters in SGTech, and our AI and HPC chapter is literally the newest chapter amongst the others here right now. I think the key thing is what we really stand for is really driving it. Well, first of all, bringing awareness of the promises of artificial intelligence to our organizations, big or small, in many different ways, and really driving the broader adoption of AI in our digital economy. Then I think the second thing is really championing the ethical use of artificial intelligence itself. And I think when we think about machines and algorithms being able to make decisions for for whatever scenarios and data that is being thrown at, we have to be sure that it's not just only what the algorithms and what these fantastic machines can do, but really what it should do. And I think it's really about amplifying our human ingenuity and creativity, rather than just a productivity type of thinking as we apply AI into a lot of the business processes and customer engagements, and also the way we think about transforming our products and services. Now, we have various events and initiatives in this chapter. So I really encourage you guys to reach out to Wansin and hopefully join our chapter. We'd really like to grow this community and be able to think about all the different interactions that we have. And one of the things that we've done is, for example, the industry outreach by AI Singapore, which you will hear from Lawrence Liu, who's leading that organization at NUS. And also some of the activities that we've done in the past before, like we recently, well, this was before the COVID-19 pandemic kind of restrictions itself. We had a visit to the Jewel at Changi Airport, and behind the scenes on a look at how some of the intelligent technology that's being used to run the whole facility itself, which was really amazing. It was really good. We had a lot of good feedback from our members as well. So with that, I like to really think about today's webinar itself, really in the biomedical field. It's certainly a huge spotlight on that field right now, and hopefully you get a sense from our various speakers who's come in to support this event with their industry views, as well as some of the experiences that they've had. So we have first of all, I think what we're starting with is the sharing by our industry practitioners on the AI-powered robots for business transformation. Dr. Atikan from Nvidia, partner of ours, he's on the EXCO of the AI chapter, really glad to have him, as well as Mr. Ken Chua, who is the Managing Director of PTC Singapore. And at the same time, we also have an academic viewpoint of AI-driven human-robot collaborative systems. And this is with Professor Marcelo Ang, Acting Director of the Advanced Robotics Center at NUS as well. And then finally, really, wrapping it all up, is he is Lawrence Liu. He's also our AI and HPC chapter advisor, Director of AI Industry Innovation and Makerspace at AI Singapore, who really talk about some of the available support and resources to kickstart your AI journey. So we have a lot of participants and representatives from the industry here online today. So we hope to have lots of Q&A and robust discussion. And hopefully you will find this afternoon a meaningful and insightful one. So with that, I hope you enjoyed the rest of the webinar itself. Thank you very much for taking the time. Looking forward to interacting with you. Over to you, Wansin.
All right, thank you so much, Richard. Right, so all of you have heard from Richard about the very exciting agenda that we have today. Right, so I'd like to now introduce our first speaker for today. That's Dr. Atikan Karupia from Nvidia. He's the Chief Technologist. And Dr. Atikan guides researchers and developers across development centers and disruptive startups to implement actionable solutions leveraging Nvidia's software and hardware capabilities. Right, so with that, Dr. Atikan, over to you.
Thank you, Wansin, and glad to be with the fellow members here. I know Richard, Prof. Marcelo from NUS has been working quite some time. So I'm going to share my slides. Just give me 1 second as I get the permission to share. Okay. Okay, so it should come through so that it's visible. Let me just enlarge it. Okay, so I'm going to cover an interesting topic. I have 20 minutes, so I cut down number of slides that I could actually use that to communicate and put some of the images and also continuous video frames so that you could understand how today autonomously capable and AI-powered robots help process automation, regardless whether small or big, and where they are residing. It could be something which is soft, or it could be something which is physically can be seen. In short, Nvidia has been established almost 26 years ago. We started with the gaming and design, and we have gone into HPC, deep learning, and machine learning, and now we have what we have seen in the last 10 years. AI is actually became a vertical specific and capable. Deep learning is one of the component of it. It's capable to perform specific tasks. So that means you don't have a general AI which is designed only for transportation. which is also capable of doing that. But we have seen more specialized AI, which addresses each and every vertical. It could be in terms of autonomous machine for robotics. It could be AI for healthcare, or it could be AI in the 5G environment. So we see more and more specialized AI, or in this case, deep learning, or specifically neural network being designed and being used. And Nvidia has been glad to be the pioneer who actually started with more than $3 billion investment in this 10 years ago by our CEO, Jensen. Now, as we look at the whole industry transforming themselves, we see three key components to it. One is, of course, AI, the deep learning, machine learning component that we're already well aware. The next is what we look at, the soft and hard robot working hand in hand to solve a specific problem. So when I saw, when I see the landscape, when I look at robots, of course, the physical one, which we can see, but there's a lot of soft robots, which actually automates a lot of processes. It could be as simple as, it could be OCR, letter recognition. So why is it letter recognition so important? It could be a production floor where specific characters being imprinted on the PCB board or on any type of electronic equipment. Today, it could be automated by certain processes, which is non-AI based. It takes a longer time. The defect rate is very high. But in order to recognize the letters by using AI and deep learning, you get almost 99% of accuracy. So that's where the soft robot comes in, to look at and inspect even letters, to do classification or clustering and so on. And by looking at these two components together, autonomous is very, very important. That means they can operate without or with minimal intervention of human being into this. And this is only made possible if you have the whole environment which can work together. It's not only the robot, it is not the human who's actually assisting the robot, but also the environment around it can work together hand in hand. So I call it as a fully automated, whether internal or external environment, which actually works together with a soft or hard robot. We'll go to an example from the space of manufacturing. It could be a medtech that we see from whether it's a semiconductor, whether like electronics, whether it's a component or assembly or cosmetic or pharmaceutical. What we have seen from our past 10 years of experience, even 1% of incremental yield for one specific sector, it goes into millions of dollars of saving or additional revenue being brought in. So that's the impact which is AI has brought in to all these sectors. And we always ask, what is exactly is your pain point that you're trying to address, right? And what exactly you're looking at. We get various input from each and every sector. It could be yield or throughput increase. It could be in terms of quality of test inspection being done, in terms of workforce optimization. It could be health and safety. For example, during this current pandemic environment, safety becomes very important for the people who are working in the environment. I'm going to share a quick, simple examples how we have worked with partners and how they're actually transforming the entire manufacturing pipeline and flow, right? So this is one example we have done with one of the company, Musashi. So I'm just going to run a simple video clip how they incorporated defects inspection. So over here, they have a specific automotive component where this automotive component being checked by a specific, I call it as automatic optical inspection device, right? It actually looks at it and finds for defects. So they've been working with Nvidia quite some time, and we looked at as one of the sample reference case to do the inspection of the defects to be done. They wanted to automate the entire flow from all the way where the parts are being brought in. That means there is a hard robot where the hand is, where it actually moves the objects to the AOI inspection camera. And then next is the soft robot, which is basically the defects detection robot. In this scale, is basically it's a neural network algorithms. It could be any type of algorithm. It could be mask RCNN, it could be Inception Net or Retina Net, and so on. This neural network has been trained on their specific data set so that they can detect even a minute defect, so that they can improve total yield or product speed that they can go through, or throughput they can go through. It could be very small JSON type of platform, which is resides within the environment itself where the inspection is taking place, or at the back end, how they train, because it actually creates a lot of data set that you need to feed into today's traditional neural network that we have, which is very much trained based on data set. They train using our high compute data set, high compute GPUs. So next is, if you look at it, how they've achieved the end-to-end industrial inspection. Briefly, so they use our SDKs and libraries where a continuous video frame comes in. In this case, I'm taking video as an input. You could even have a text and string as one of the input as well. So as the continuous video stream comes in, it could be 10 frames per second, it could be 30 frames per second, or even 60 frames per second, based on the how fast is the AI machine is actually rotating and the camera capability. And looking at in terms of the type of images, it could be high resolution, it could be low resolution, it could be RGB, it could be raw, any type of images. As it comes in, the algorithm, which is used using our DeepStream SDK, able to pick up what is right, what is wrong. Now, what is right, what is wrong? What is normal, what is abnormal? What is defect, what is not defect? We don't know. It is a specialized industry vertical. The people who are experts in that industry will able to define this is abnormal, this is normal. So we facilitate in terms of entire pipeline of what we call transfer learning toolkit for your neural network training. So you take the data set, you augment the data set, you label it, and then using this labeled data set, you can train the soft robot, so-called the soft robot, which identifies a specific defect or abnormality within the object that you're looking at. And then of course, retraining to be done, and then you optimize the network before you deploy in a production flow. When you look at production flow, there could be multiple pipelines is running. Each and every pipeline may do a specific task, may be different than the other pipeline. They may have many phases into it. Each phase may be slightly different. You need to train a different type of neural network. Even within a phase, within an object, there could be multiple classes of defects. So we need to look at each and every class of defects. A neural network has to be trained specifically for every class. And even subclass, so that you can get almost accuracy that you are happy. Some of them happy with 80%, some of them happy with 90%, some of them they are happy with 99.9%, right? So based on the defect rate, you could train your data set. After you train, then you do a deployment, or what we call inferencing. So the inferencing can be done within the factory environment, using models that you have trained, and you can easily deploy. So that's how the entire end-to-end process was done together with a specific customer like Musashi here, which I shared with you. Now let's look at that is basically the soft robot working with the arm, which is the hard robot I call. Next, let's look at how BMW has been working with Nvidia to have the hard robot part of it. In order for me to illustrate, if you look at it on the top there, it's actually mapped. Where the robot is going to move around on a specific floor. It could be a factory floor, it could be production floor, it could be office floor. That's where your LiDAR comes in as an input to capture and understand. The graph here just shows how do we work with the manipulation of the robot to do a specific workflow of a task in a certain environment. And on the far right, if you can see, there is a visualization from the top view how the robot is moving. On your left-hand side, if you can see, this is a vision of the robot. That's how the camera within the robot allows the robot to see, or perceive and understand the external environment so that it can react to it, right? And on the right-hand side, which is our eyes are watching, it is actually how we see virtually. For your information, this is virtual environment. That means nothing is physical at this point of time. This robot virtually being trained how to move within the factory floor, and then goes to a specific object, which is again virtual, so that it knows exactly to reach the object, to get itself to be docked, and then move the object. So this is what we call virtual training to be provided to the hard robot, in this case, wheeled robot, to perform a specific task. Now, how this happens in the actual environment, this is the physical robot. In this case, it does object picking, we call, right? This is another physical robot which moves, and if you can see, this is the physical robot which has been trained previously for a given environment, and it can operate as per the instruction given within the virtual environment. So given the challenge of how do we train each and every physical robot, what Nvidia is doing is train the robot virtually and then transfer the knowledge of virtual intelligence into a physical robot, whether it could be arm based. So in this case, if you can see, the arm is doing the picking the object, but over here we simulate the entire maybe in this case I want to share again. In this case over here, if you can see, this is a virtual robot. This is a physical robot at the back end. This is a front end, the virtual robot. So the simulation actually correlates back to the actual operation of the arm and making sure the operations perform to the accuracy for the given environment where the robot is working. So this is how today the AI or deep learning has moved in terms of training the robot, not anymore by mechanical machine instructions, how many millimeter you're supposed to move right or left, into more educative, easily interactive manner to train the robot to do a specific task. Right? That's where the industries are moving towards in terms of incorporating AI or machine learning for autonomous machine capability, I would call. This is again how the whole simulation activity has been done. As we know, those who are playing games, we actually interact with the virtual world. And today, with the high resolution and capability of AI, you have a very super resolution. Looks like as though it is a very close and a very real photorealistic image. But this is how we train today arms of robot to do a specific task, to do pickup in this case. But the order of pickup of object previously is based on color. So in this case, I can say you should stack blue first, then followed by yellow, and then green, and then the red. The robot arm can understand the color. It then translates in terms of pickup orientation or stacking orientation. So that can be done. Again, which as I shared for the case of BMW, this is how they simulated the environment before it performs a specific task. So such kind of operations of training and making it learn intuitively by itself for a simulated environment helps us to teach the robot to be independent for the given situation and scenario, right? This is what being done in industry today with our partners. Now, how is it being done? Very simple. You have a simulator which allows you to do simulation of the environment. You have the model training, which is basically neural network models being trained using our GPUs. Later, PCT Can, who is our partner, will able to share with you about all the hardware environments available. And then you deploy in Isaac environment, which is basically a Jetson platform. We provide entire SDKs. We can discuss more. Prof. Marcelo will be sharing later. He's using some of the platform here in his lab in NUS, and he's creating his own algorithms. In Singapore, we're working with the ecosystem, for example, with GovTech, has been experimenting with the Isaac SDK for the outdoor robotics. And as I shared earlier, Prof. Marcelo also, it's a partner of Nvidia working on using the platform. Now, coming back to soft robot, what does it mean? This is in a simple environment. Of course, in a COVID situation, we want to apply video analytics, for example, right? So in this case, if you can say this is a region of interest and you have an object of interest in terms of people, that's how today a camera, which is AI capable, automatically count. It's a very simple task that we can be done, one specific neural network. Now, given the same neural network, we can ask to do something else. We train something else. For example, in this case, social distancing, whether a social distancing taking place in an office environment or factory environment. So the two person over here, when they come very close to each other, there is no social distancing. So the distance itself could be designed within the AI algorithm so that it can pick up and demonstrate whether people in a specific environment behaving as they should in the pandemic and kind of situation. This is another example how the soft robot actually works by looking at an object. Even in this case, both are moving. The front vehicle and then the back vehicle where the camera is mounted, both of them is actually moving. But again, it's able to pick up For in this case, for example, the maker, the model, even the vehicle number, even though it's far away. So that's how two soft robots can actually work together to detect even minute, small information as simple as car maker and even the car plate number can be done today by soft robot. Now, putting all this together, for example, this company called Chuk actually brought this into operationalization in a normal environment, office environment, hospital environment, for example. They can detect if the person is coughing because they have a sensor for audio. They can detect mask. They can even detect whether the person is actually washing hand in a right manner. Just for example, in the case of COVID-19, we want to make sure all the employees adhering to the guidelines of health specific rules and regulation that a company may have. So all these can be automated as a soft AI robot. In this case, whether we want to have, for example, contact-free environment, how do we ensure there is no contacts? In this case, hospital environment, we can detect the movement of arms and then to the specific object, for example, a table, whether there is a contact has been established or no contact. Similarly, we can, for a given doctor, whether the doctor is wearing glove or not, all this has been implemented and has been operationalized by our partners who have used AI. Next is, I want to touch how today we are bringing multi-modal capability. It is not only audio, but we can combine video together by using neural network in a simple example here. So in this case, autonomous vehicle, where it is, there's a vehicle here, the two person having conversation.
The nearest Mexican restaurant is the Mexican Kitchen, located at 1495 de Alameda, San Jose.
So they're talking to a soft robot here. Right?
It is currently 66 degrees and sunny in San Francisco.
Actually, you know what? I'll be building sushi.
Really?
Yeah.
Alright. Show us the Japanese one.
The nearest Japanese restaurant is Aniki's Sushi, located at 3810 Maury Avenue, Fremont.
It will be mostly cloudy with a high of 62 and low of 54.
If you can see, the two person actually mixed a conversation about when she asked how about tomorrow, they are mixing with the sushi restaurant, right? If you can see, the AI is capable to have a contextual based conversation. There is a context to the conversation, location versus weather. It knows who's the person looking at and talking to, and then they can put that together to have a conversational AI. This is another work that Nvidia been working on for some time. Is already being deployed in some of their environment. Right, I'll just skip to this. The next is we are looking, we also have many of our partners looking at modernizing the entire warehouse. For example, I'll share with you a short video clip how Ocado in UK has modernized packaging of objects, but is basically it is customers who actually order in Singapore today. No specific company that I want to refer to. A company that we go order online for our grocery, and the grocery being delivered to us. Today, Ocado actually can process almost 65,000 orders in a week by using robots. So these robots actually works hand in hand, where they can receive the order, which is all comes in through a software system, and then it picks up a specific order, and this particular order actually requires some objects or item to be put into a specific container. Each container actually associates to one person who added some kind of objects, and each of these boxes that you can see actually being loaded with the objects or loaded as a groceries in this case, and then they can move the groceries into a specific box which is targeted for a specific order. Now this actually reduced or transformed entire warehousing concept by using AI and deep learning augmented together with the robotics capability to do packaging in this case, right? So we can see here, AI is actually looking at the object, counting at the object, making sure the order actually fulfill per the request, per the item that they have. Now, in the interest of time, I just want to share the AI in the space of manufacturing is gone beyond just automation, both hard and soft, even for example, in the molecule level, material design being done by using AI algorithms, in this case by Samsung. Next, we look at in terms of using AI to do electronic health record optimization, where you have billions of data comes in. This could be text and string type of data set, non-video. Even in the case of medical, where the doctors and also the specialists actually trust the AI system to assist them, to help to sort out all the information so that they can get into the right information they are looking for. And same goes to in terms of drug design as well. In terms of manufacturing, even wafer defects inspection, it will be very minute on the large wafer. This is being done by our partners as well. So with that, that covers my 20-minute session, what I wanted to share. Pass back to you, Wanzin. Or in this case, Ken and my partner will continue with this session.
Yeah, thank you so much, Dr. Atikan, for the very comprehensive insights. So right now, we would move on to a sharing by Mr. Ken Chua, Managing Director of PTC Systems, to shed light on how it actually ties in, how the work by PTC actually ties in, right, with what Dr. Atikan had presented earlier. Right, so just to give a quick introduction, PTC Systems is a major provider of IT and business transformation solutions with initiatives in machine learning, AI, data analytics, etc. So I'll leave Ken to share more with the audience. Ken, over to you, please.
Thank you, Wansin. Thank you, Dr. Atikan. Good afternoon, everybody. Thank you for joining us for the SGTech Future of Biomedical Industry with AI webinar. I'm Ken Chua, Managing Director of PTC System. Today we are going to take the session to update you on how our customers in the biomedical and manufacturing sectors are coping and rethinking of operations and digitization during the pandemic, and also how enterprises are embracing IT transformation. And these are in the area of automation, hybrid cloud, data management platforms, and particularly to drive the heavy AI computing requirements. That's the area of GPU integrated infrastructure that is optimized for data science, AI, and Industry 4.0. Right. A short introduction about PTC System. PTC System is a leading data management provider. We are established in 1991, and we have been serving the enterprise and manufacturing sector for the last 30 years. We are EPU S10 status approved vendor, and we focus mainly in the mid and enterprise market, and we across the different sectors, and we have offices in Singapore, Malaysia, Hong Kong. So for FY 2020, at a glance, what I'd like to share is that this pandemic, we observe that it has forced enterprise to relook on how they can operate remotely and work from home securely. So and in part of that, we see that the COVID-19 has become the main catalyst for the tech adoption, so that they can manage their operations, access their plants. It could be in the region as well as the market in the region. And in embracing IT transformation, cybersecurity, we find that it is most critical, especially now that a lot of us, we're all working, the new norm of working from home, and then especially through like solutions like remote management and desktop virtualization. Also looking at the past 6 or 7 months or so, we've seen a lot of embrace of solutions in hybrid cloud infrastructures and services. And this is a platform that organizations use to manage from the core data center to multi-cloud as well as to the edge. So the other area of IT transformations that we see organizations are embracing are in the area of RPA, robotic process automation. That's for the automation of the business process. So there's basically two parts of that. There's another part of the automation that is like a automation platform for IT operations. So that's very much in terms of automating manual and repetitive tasks in the IT operations. So for those that took a bigger and more sophisticated solution, these are the ones that Dr. Adigan talked about earlier. So those are solutions based on machine learning, deep learning, AI, as well as data analytics. So what I'd like to share here is that Industrial 4.0 has become a reality for modernization, and that you heard from Dr. Adigan earlier, those solutions like virtual trainings of robots and let's say and virtual training using imaging and all that, they are very compute intensive. And this is the very reason why at the heart of digital transformation, we see the need to combine both a GPU integrated infrastructure as well as a hybrid cloud platform to help you in your data management. So in terms of the solutions, what I'd like to share is under the smart manufacturing, these solutions are now available, and it is also a solution that we are pushing quite a fair bit into the area of real-time multi-video streaming, monitoring for health and social distancing analysis, area in the machine vision for smart manufacturing. Those are area for automated defect detections with the utmost precisions. There's another area would be in the area of setting up of data lakes and data preparations for predictive analytics. And that's to also help you to develop business insight. RPA is another big area. So RPA very much in automating business processes, and especially relevant now because of the issues of worker shortages, and also during this time, many are facing also logistic disruption. So the last part very much so is in the area of automation platform. And I mentioned earlier, IT operations, especially those manual and repetitive tasks, that all can be remotely controlled and automated. Yeah, so there's a lot of work that can be done in terms of driving solution for smart manufacturing. The other big part is in the area of IT transformation. So these are like the building blocks. We spoke about the building blocks that's required, right? In this area, hybrid cloud platforms, automation platforms, some of these solutions that put all this virtualization, compute, HPC, storage, backup, and all that together. Those are the building blocks. And in terms of these solutions, solutions involve, we felt that with cybersecurity is most critical at this point. So those are solutions, for example, like the Zero Trust Network, manage detections and response, security posture, CASB, PAM, network access control, and area also in the area of machine learning based APT. Those are for detecting advanced persistent threats so that you are protected against malicious attack, right? So those are key areas. Mentioned earlier also about the hybrid cloud to modernize your IT so that you can deliver powerful performance and it is scalable. You can move data to the cloud, multi-cloud, managing that, and also moving it back to data centers. The last part that I'd like to highlight is one big area that we help a Singapore company a lot is in the area of data management. So that's in the area of solving issues of data proliferations that sit on silos. And you know, there's so many silos now sitting, right? It could be on the multi-cloud, it could be on your data centers. And this data platform helps you in terms of data consolidations, file service, data backup, data archive. And these are very good solutions that we have seen a lot during this period. So in summary, IT transformation and business accelerations, business automation has been accelerated, and we are your partner. We will be able to help you in driving these two major initiatives. And basically, these are our partners that we work with for the digital transformations, and we look forward to work with you. So, yeah, so this is the part that I'd like to share with you all today. Back to you, Swanjin.
Thank you so much, Ken. Right, that was again very insightful. Right, so now we are going to switch gears a little to hear from our academia. Right, what are some of the insights that we have pertaining to the area of process automation for the biomedical sector? Right, so we're happy to have with us today Professor Marcelo Ang. He's the Acting Director of Advanced Robotics Center at NUS. So Prof. Ang will take us through key concepts of AI-driven human-robot collaborative systems. Prof. Ang has vast experience in areas of robotics, mechatronics, and applications of intelligent systems methodologies. So in addition to his academic and research activities, he's actively involved in the World Robot Olympiad as a member of the Advisory Council. So here, over to you, please, Prof. Ang.
Good afternoon, everybody. I'm happy to share with you some perspectives from the academic point of view in terms of research and how AI can form an important role, crucial role, in making the robot the ultimate human assistant, the ultimate tool, the most intelligent tool to make all our lives better. So let me go through some quick review. People say this today is Industry 4.0, but if you look at how tools have evolved to make it better and better, right? The key now is autonomous robots, where they can operate in environments designed for human beings. It's not only in environments like factories, where they are designed for machines, right? Where this is characterized by unstructuredness of the environment and also characterized by the human nature. In other words, the human is mixed intimately with machines. In other words, bringing the robot out of the factory in Industry 3.0 to Industry 4.0. I wouldn't even call it Industry 4.0. I would call it daily life 4.0. It's everyday robotics. So the key is, what do we do to move from the left to the right? You can see in the left, the human being is out of the factory, right? There's a cage, the robot inside the cage doing welding in Michigan, United States, of cars. The robot just welds. The robot doesn't need eyes because the environment is structured. The robot can move exactly the welding tip to the proper point of welding without seeing what it's welding. So if a human goes in, it will just weld the human being, right? So of course, when the gate opens, the robot shuts down for safety. But in the right, this is the shopping mall, grocery aisle, a hospital, our home, and the list goes on, education. This is really everyday robotics. How can we bring these robots from the left to the right, this arrow? The left is characterized by two keywords: structuredness, everything is known. Human, robot are separated. On the right is unstructured, and there is a close mix between human and robot. So the research challenge, technology challenge is, how do we move these robots into everyday life where the space is designed for human beings? And a key missing, or a key solution, is artificial intelligence or machine learning, and how we can embody how humans learn, give this capability to the robot, right? So the robot needs a good brain, but a brain alone, AI alone, just moves data, right? Moving data without a body to physically do things for us, right? Our everyday tasks is not as useful, right? It's useful. We see the impact of IT and AI in data manipulation. But in addition to that, if you provide that data intelligence with a body, it can now do things that we do not want to do. It will be the ultimate tool for us. And these things are called 5Ds. These are dirty, dangerous, like climbing up buildings, demeaning, degrading, like cleaning toilets. And the fifth D, I work on it 10 years ago, is driving cars or vehicles, right? Because in this fifth D, not only are humans too intelligent to be doing this mundane task, but for autonomous vehicles with the computer driving the car, it can potentially be safer because more than 95% of accidents are caused by human errors. It's no brainer why that is potentially possible, because the car sees more than what human sees. The brain of the car is a computer. It doesn't get tired. It doesn't get sleepy. It doesn't get emotional. If somebody overtakes the car, never mind, you're still cool, right? So for all those reasons, but the key is, why don't we see cars today that are driverless, right? Because there's still challenges. And the main challenge is really, how do humans drive a car? How does the human know when to overtake? Can we create mathematical models to describe that, right? And that's the key. That's why there's a lot of interest in putting algorithms into bodies. And for these algorithms, we need AI engines. So I'm very happy to see Etikan, to hear his presentation. Nvidia is a very good partner for all of us in how we can work together in making this a reality sooner. So these are the 5 Ds: no mundane, no demanding, no Ds, and robotic is a key solution, and especially important in Singapore, because in Singapore, what is our main resource is manpower. We don't have anything else. It's knowledge, the intellectual property to do things, to be able to use the existing tools, so we can improve productivity. Even when I grow older, we all grow old, our brain is still active, but we can still live meaningful lives, right? Contribute to society, because as we grow old, we have wealth of experience. Can we transfer this experience to the machine, right? Unfortunately, we don't have the luxury for the machine to grow 80 years old, right? That's the beauty of simulation. Nvidia mentioned, Etikan mentioned Nvidia Isaac platform, which is a very nice simulation environment. Can we fast forward 80 years of experience into 1 hour of simulation? And can I transfer my intelligence of driving? I think I'm an expert driver, having grown up in the Philippines. That's the best place to learn driving. Can I transfer my brain to my son, to my students, so they instantly become expert drivers? We cannot do that, right? Humans have to learn from experience. But with a computer, a neural network trained for certain tasks can be generalized and learn to a different task. And that's sort of the holy grail of AI. So let's look at tasks we do every day, right? Starting from the very simple task, something like this. Let's say here, simple task like a washing machine, right? What does the machine do? The machine does everything, right? It knows when to stop, but the human still has to do something, right? The human has to still set up the time, the wash cycle, etc., right? But if we try to improve technology going down for the same washing machine, maybe we want to make the machines more intelligent, bring this up and bring this down, right? So that the human doesn't need to do as much. Maybe a future washing machine, there is already some talk about a fuzzy logic controlled washing machine using AI, where the cycle of wash depends on how dirty the clothes are. Now, when you're given a problem like that, one would think, how does a human know when you're washing clothes manually whether clothes are dirty or not? Very simple. You look at the water, right? If the water is turbid, it's dirty. If the water is gray, dirty. If the water is black, it's very dirty. So all you need is a sensor to see through the water, to see how much light can transmit to the water. And from there, you can have some algorithm, common sense algorithm, to regulate the washing cycle, right? So, okay, so that's good. But maybe we can even go further to make it better. Maybe I want my washing machine not only to wash clothes, but to dry it also. And not only that, when it come out, it's already folded neatly. That is the holy grail, right? Ironing clothes is so hard to do that. So life is all about that. It's all about increasing this curve, make the machine intelligence better and better, so the human gets doing less and less, right? And if you look at here, another scale, a more complex task is vehicles, right? How do vehicles drive today? We have seen how machines become more intelligent, auto parking, lane keep assist, lane following, adaptive cruise control, level 3 automation, what they call for AV. But of course, Singapore, as we all know, we're working toward level 4 and 5, physically driverless. And so we're looking at here that we can have the car just drive for us, and we don't need a driving license. We don't need a safety driver. So how can we do all of this, right? It's really developing algorithms that mimic how humans make decisions. And that is super hard, right? And it involves 4 things. Sensing, you need to understand the environment. Sensing is not only seeing what things are, knowing where we are, for example. Localization, for example, if I open my eyes, I know I'm at my home, right? Because I recognize my home. I don't need GPS for that, for example. If I'm open my eyes, you transport me to the hospital, I open my eyes, I know I'm in a hospital. How do I know I'm in a hospital, right? Well, because I've been to many hospitals already, right? So understanding the environment, number 1. Number 2, planning what to do, right? To do the task. And number 3, to execute the plan as accurately as possible. And number 4, to continuously learn. So this is a loop that we do all the time as we live through life, right? Now, in my objective of moving robotics to everyday robotics, 10 years ago, I started thinking, what is the everyday situation that is most interesting, most challenging, so I can do a lot of research and contribute in science, number 1. And number 2, has the biggest impact to everyday life. And I think the answer is very clear, transportation. Because everybody needs to be mobile. That's why I like LTA's logo. We keep the world moving, right? Yeah, without, whether you're rich, poor, you need to move. And whether you're young, not old enough to drive, you need to move. You have too much to drink, you need to go home, right? You're too old, you still need to move, right? And unstructured environment. How can I look at our roads? That's the most unstructured environment. Look at our malls. When you walk around the malls, our MRTs, that's unstructured. So an autonomous vehicle is an excellent application that I'm very happy to be part of, as Singapore is actually leading the world here. We have developed the first technical reference already, and that technical reference for AVs in Singapore will become an ISO standard in 2022, hopefully, and we're already in the DIS stage. We already passed the CD, the committee draft stage, so we're still working with LTA as Singapore's one team to the ISO organization. So the brain, how does the brain do these 4 things? There are 2 basic approaches. The standard approach is model-driven. Model-driven is, let's say the input is, let's say, driving car, right? The input is what you see in the road, right? The obstacles. What you see is your what input is your destination, right? What's the output? How you turn the steering wheel, how you press the accelerator, when to press the brake. So that's the physical phenomenon called driving. The traditional approach is we create a mathematical model, an equation, right? Like y is output, input is x, we have f of x. Y is f of x. Now, can you imagine how can you derive a function that will relate x to y for driving vehicle? And if we have that, then it's very easy. If you want your y desired, then x is just the inverse of your y desired, right? Simple, you don't need anything. We control the world based on our understanding. But we know that's very difficult. And the first breakthrough, if I may say so, is recognizing objects. How do you know something is a dog, something is a cat, right? And if you can use this function f to do that, and people have tried that, but it's not so robust. And how we recognize something is a dog, something is a cat, or somebody is a woman, somebody is a man, right? We learn from experience, right? So somehow the brain learns from experience. So all we need is data, and data is a baby grows up. The first thing he or she sees, mommy, daddy, and sister, broader, then he begins to associate, oh, maybe there are two kinds of people, a male and a female, without even people telling the baby that that's a male or female. The baby just knows there are two kinds, right? Actually, the word male and female are artificial constructs. We just label them. Although today it's getting difficult, right? I'm sure you've seen people, is that a guy or a girl? Yeah, so it's very challenging now for AI too. Now, can we have AI to be able to even learn this? So perhaps it's not only the face, the body gestures, right? Even the voice, right? So using the sensors to understand. So we are also building a model of this physical phenomenon, but that model is a data model. It's not based on common sense. It's not based on Newton's law. It's based on data, right? Big data. And there's still, and we know the algorithms for doing that. The algorithms are based on neural networks because the neural network is a primitive approximation of the brain, and the brain has neurons that connect together, and how these brains work is really learning from data. We have algorithms to do that, and the training of the neural network is really simply an optimization problem. Given the data, how do you optimize the parameters of the neural network, right? So that the error or the loss is minimized. The question is, among these two approaches, 1 and 2, which is to use, right? The best, of course, is a hybrid method. For those, we have a model. Why don't we use the model? But we know models are never accurate. From the errors in the modeling, can we use the errors as a data to improve the model, right? So that's good. Another way is if you don't have the model, like driving cars. I don't have a model how humans drive a car, right? So what do? I just show videos of people driving and capture what is the input, what is the output. All I need is the input, output, and do a data modeling and to create a model, an fx that relates x and y. But to do that, we need lots of x and y pairs, right? And the holy grail in AI today is, okay, you have learned x and y. What if you give it a new x or a new y? Will the model still be valid, right? That's why I call AI now better is AGI, artificial generalized intelligence. The keyword is the generalizability, right? Humans know that, right? I will be able to detect male and female. I don't need to have seen the same female before, right? I see a new person, I will know 90% of the time whether it's male or female, maybe 98%, not 90, right? And so we know algorithms. So the key is how do you know what is the parameters of these neural networks, number of neurons, what are the activation functions, what are the weights, what is the architecture, how deep should it be, right? So the hybrid is always better to combine both, and this is a continuous quest to keep doing this. So let me end with this video to show you some work. You can Google search driverless buggies to see our vehicles in action in the Japanese gardens when we showed it in 2014. But this is an attempt to bring a vehicle with an arm. So forget the vehicle, let's just do the arm. I hope you can see the video with some light music. So the idea is how can we make the robot easy to use? So the AI detects the hand, right? And knows where the hand is to hand over an object. The AI can also detect the objects, which in this case was trained to detect boxes and bottles. The AI also knows some using RGBD type camera. Instead of just vision, we also know the depth. And this is some of the architectures we use. This is simple object recognition. We need 6D because in addition to position, we want orientation. We have some simple dialogue. So give me the box, something like this. So these are all integrated to the robot controller where the recognition, an AI engine from Nvidia is running the neural networks. And we continue to use them together with a regular computer to do the other types of planning, right? To integrate all of this. So this is an existing project called Human Collaborative AI, right? And it's a part of a bigger project funded by A-STAR, involved partners in A-STAR, ARTC, and NUS. If you want to know how you sound like a 2x speed, this is how you sound like. It's kind of interesting. If you play your audio 2 times, it behave like a Mickey Mouse voice. But language processing is another area. How does the robot understand what the human is saying? How does the robot understand the intention of the human? If I relate it to autonomous vehicles, it's the same. The challenge in planning is predicting the intention of the pedestrians, the human-driven cars. Is that car going to be upset I changed the lane? Is it going to be speeding up because I changed the lane? Is it safe enough? How do we predict it? Okay, so this is the end, and thank you so much for your attention, and I hope you are motivated. And I didn't really talk about biomedical applications because robotics is applied to many things, right? But I hope this will plant some seed, some new ideas, right, on how you can use today's technology to make all our lives better. Okay, thank you. Back to you, Wan Chin.
Yeah, thank you so much, Prof. Ang. I really enjoyed the analogies during your presentation. All right, so once again, thanks to all for staying with us. We are down to the final presentation. I know we are running a bit over time, right? But thanks to all who are still staying with us to wrap up this session, right? So we'll have our final speaker next, Mr. Lawrence Liu. He's the Director of AI Industry Innovation and Makerspace at AI Singapore. Lawrence spearheads the adoption of AI by the Singapore ecosystem. He is also advisor to SGTech's AI and HPC chapter. He will share some of the key programs which the industry may participate in to kickstart one's AI journey. So without further ado, over to you, please, Lawrence.
Thanks, Wansi. Can you hear me?
Yes, all good.
Okay, great. So thanks everyone for staying back. And I really enjoyed Dr. Marcelo Ang's lecture all over again. I was in his class many years ago during my undergrad days.
Thank you, Lawrence.
But,
I'm very proud of you.
Thank you. As director in AI Singapore, and for AI industry innovation, our focus is really how do we help the industry to actually, get onto this whole AI journey. AI Singapore, for those who are not aware, we are Singapore's national AI program office, and our goal here is to work with various government agencies and all the universities, including A-STAR, to actually bring together resources to actually help industry to actually build AI solutions and products. So for example, if let's say you are super inspired by Dr. Ang's talk and you say, hey, I want to work with Dr. Ang and I have an idea, my company is keen to build this AI robot, you can come and talk to AI Singapore, and we will try to convince Dr. Ang to actually work on your project, and we'll fund him to work on your project. So in AI Singapore, we have various activities. We call it pillars. AI research, where we fund professors like Dr. Ang here to undertake fundamental research in AI. So this doesn't really involve the industry. AI technology is a separate team. And their role here is to look at Singapore-level national challenges and then create programs to try to solve some of those challenges. So for example, the one that is ongoing is in healthcare. And as we all know, Singapore has a very big problem in terms of the 3H, high blood, high cholesterol, and hyperglycemia, which is diabetes. And healthcare grand challenge is how do we slow down or reduce the progression of the 3H in 5 years. So that one, we have like 3 big research teams in NUS and NTU working on this. For industry, I run the AI innovation and makerspace. And in this, we have various programs that were created over the last 3 years that we've been around. We started only with one, which is the 100 experiments. And along the way, we created more and more based on the gaps that we identified and the needs that we identified that the industry needed. So the 100 experiments is the one that we work with the industry. For example, we have Sabana Jurong as one of the project sponsors. They came to us and they needed help. We found a professor in SMU to actually help build a predictive maintenance system for them. We have helped a SME that have launched a micro lending business with a professor from NUS. We have also helped a startup to do dynamic routing for vehicle deliveries. We have helped another startup out of SUTD to actually build a computer vision system to do imaging. This one, the professor came from SUTD, right? So the SUTD had students that actually decided to spin off. So we actually co-funded them to build out the prototype. Speech to text, Singapore is also very strong in that, in the area of Singlish, especially localized languages. We have helped IBM even to build out a predictive system to actually predict which products will have high RMAs, for example, that means returns. And we have helped Expedia to actually do natural language processing in Asian languages. So these are all what we call the 100 experiments, where a company comes to us with a problem statement. So the way it works is that, if you in the industry, you have a problem statement that you think AI can be used and there are no existing solution out there, that means you have talked to Nvidia, you have talked to SIs like PTC here, and they say, well, this is interesting, but I don't have the capabilities or there's no solution. That's where AI Singapore will then step in and we will evaluate and we'll see that, okay, this is really something worth doing. There's a lot of research required. Then maybe if it's robotics, then we know who to call. We'll call Dr. Ang and say, hey, we have this company who has an AI problem that involves robotics. Would you be interested to be the PI? So one of the things that AI Singapore program works, unlike other government grants, and I saw a question earlier, we don't give you any money, okay? We don't give you any money. In fact, you have to give us money. We will put in kind in terms of engineering resources and researchers, and we'll actually pay the money to the professor to form a team. And then you will have to put in a one-to-one matching in kind and in cash to actually, your cash will then go to the, in this case, the research team to actually develop the product and solution for you, okay? So unlike other government grants where the money goes to you and then you do the work, but in the world of AI and machine learning, even if we give you the money, you'll be challenged to find AI researchers, okay? If you are SME, it's going to be very hard because, you'll be challenged because the AI engineers, the data scientists, they all want to work for the Google and the Facebook and so on and so forth. If you're a big pharma, yes, you probably have your own team. But in this program, the premise is that we have all the expertise, or we can find the expertise within the university ecosystem or A-Star, and we can form teams to actually help you execute on the project. So in this 100E for research, the focus is very much on the research, the R&D part, where there's a lot more research than development. And for those who are looking from an IP perspective, if you put in 30% cash, the IP is jointly owned. If you put in 50%, the IP is owned wholly by you. This project is typically 18 to 24 months and is led by the professor. But we all, throughout the journey, we also found that there are companies who say, well, my project is difficult and it's really more translational. That means it's just development, taking state-of-the-art algorithm and then making it into a product or service. And you want it fast. You want it in 3 months, 4 months. So we created another program, we call it 100E for industry, where it's more of development than research. There may or may not be a professor involved, but AI Singapore, with our engineering team and our scientists, will actually lead the development for this. And this is typically executed in 9 months. Okay, and in this case, the focus is really on two things. You still have to put in money, you still have to put in manpower, but the focus is actually building your own AI team. That means you want to use this program to actually build your own AI capabilities, right? Where you come together with us and we build a solution together and you learn. And you own the IP. In this case, we are not interested in the IP. You see the word apprentice here. Apprentice will be assigned to the projects. Apprentices are not students. They're actually working adults, professionals who actually quit their job and come into the program. And you are encouraged to hire them. So they have worked on your problem for 9 months. And after 9 months, they are available for you to hire. They are looking for a job anyway. So the outcome actually is all about building a AI minimum viable model, which you can use, and then training Singaporeans, which you can hire. Okay, so this program has been wildly successful in training a large number of Singaporeans AI engineers. So that's how we came about from the 100E. And one of the challenge that we had when AI Singapore started was finding AI talents. So we created an apprenticeship program that lasts 9 months. And we basically take on Singaporeans who self-taught themselves AI, machine learning, and then put them to work on your project on the 100E. And in doing so, we were able to train nearly 137 today. And by the end of middle of next year, we'll probably get about 200 Singaporeans that will have gone through this program. All which, after training, they are released back to the industry. And AI Singapore, we actually use this same program to hire our own engineering team. So today, I mean, not today, but let's say before COVID, if you walk into our office, you'll see that we have more than 95% AI engineers are all Singaporeans. We do have foreign talents, only a handful, maybe 2 or 3 of them, but the rest are all Singaporeans. And I have about 30 engineers today, and we're growing to about 60. So that's we created the AIP, and along the way, we found that there was also a lot of need to educate the industry, and we created more programs like AI for Everyone, basically to demystify AI, because a lot, what Dr. Ang shared was super good, right? I will copy some of his slides and include it into the AI for Everyone, to basically demystify AI, because there was a lot of misunderstanding what AI is. And we also had a lot of requests for, okay, I've gone to your AI for Everyone. How can I learn more? We created AI for Industry to enable more working professionals to pick up AI. We did not start professionals. We created AI for students, AI for kids, to make sure that I have a big pool of students, right, coming into the whole program and being STEM aware and join the IT industry and hopefully, AI. We created AIP Field Guide for the more geeks in this audience. If you want to know what it takes to become an AI apprentice, you actually need to know all of this even before you come into the program. So you cannot say, I want to come in and learn Python. No. You learn Python on your own. You learn machine learning on your own. You take a test and you pass, then you get accepted into the AIP program. What about the small and medium-sized enterprises? So we created what we call a makerspace, where we have solutions, we have pre-built solutions, we call it breaks. We'll be creating platforms, we'll be putting up data sets that SMEs can come and tap on. And we hope to tie in, bring in solution providers that the SME, because like I say, if your problem statement is not so difficult, we are not likely to do a 100E with you. We'll recommend you to a system integrator. But it wasn't enough. SME needed a lot more help. So we created other programs to basically educate, explore, discover, and to help prepare you to get onto your AI journey. So yeah, so we even created certification for the whole industry. So today you can actually hire certified AI engineers. It's new. We are in the second run. I think we have about 100. We'll probably get to 100 by the second run. 100 certified AI engineers in Singapore today. So we have other plans. We won't be able to share it today, but happy to take any questions. Thank you. Francine, back to you.
Yeah, thank you. Thank you so much, Lawrence. That was again a very comprehensive download of the various support that AI Singapore offers to the industry, right? So thank you once again to all our speakers. I'm conscious of the time, right? So what we'll do with the Q&A is that we will address the questions, right, that has been posted here over in Zoom, right? And for those of you who have further questions, you are free to stay on, right, if you wish to interact directly with our speakers after we have closed the webinar. Right, so we have a question here from Venu saying that it's good to hear about soft robots used for inspection. Any experience in using soft robots for visual inspection of raw materials like bags, bottles in the pharma and biologics industry? Right, so maybe I'll pose this question to Dr. Atikan and Ken, either of you, to address it.
Hi, Wanjin. Yeah, certainly, from Nvidia perspective, we don't provide the end solution. It's all developed by partners who are working together with us. Certainly, I know there's work done in terms of glove manufacturing, for example, which is very similar to plastic-like or soft kind of environment. We know startups were actually doing automatic bottle waste material classification. So yeah, certainly it is being done, definitely. So it could be bags, bottles, as I can see. And in terms of biologic industry, in terms of pharma, yeah, pharma is a big adapter of an AI. We have seen many types of adoption within the pharma industry. It could be almost, atomic level to molecule level to, biological basic structures or proteins, for example, AI being adopted.
Right. Thanks, Dr. Atikan. Ken, anything to add from your end?
We have worked on projects that not so much on, say, bottles and so forth, but we do work on project on like the looking into the wafer, looking into the semicon area for manufacturing, and there are really good use case on those kind of solutions for defect detections.
Right. Okay, so for the audience here, if you are keen to find out more about these use cases that Ken and Dr. Atikan had mentioned, right, feel free to reach out to our speakers later. Right, so we have a question
We'll
from
be more than
Venu.
happy to cover their questions in detail.
Yeah, and we had another question from the audience, again from Venu. And I think earlier Lawrence had addressed this part about the funding support from government, but there's the other side of it, which is around the process towards pursuing feasibility studies for using robots in the Singapore industry. So maybe for this question, I'd like to pose it to Professor Ang to address. Or Lawrence, if you'd like to chip in as well.
Yeah, so I from AI Singapore, we don't have any grants to companies that I mentioned. 100E doesn't give you grants, but if you are keen on 100E, yeah, we will co-invest and get Dr. Marcelo Ang to work on your project.
Yes.
If it works, if it fits the 100E. But there are other grants from ESG and so on that the R&D grant, the POC grants and so on, which you can go to. And in those cases, they actually give you the money to actually execute the project on your own and probably in collaboration with the university.
Correct. For example, the productivity solutions grant, there's one that gives up to 80% subsidy. And this grant can even start with the feasibility study first, right? It's not the full proposal, just to feasibility, just to study the problem, right? I'm sure you can talk to Enterprise Singapore. That will be the one-stop source for this, Venu. Yes. So thank you, Lawrence. I'm very happy to work with AI Singapore, right? And to work on really impactful problems that will really work. I think I view it as a really nice combination, the brain and the body, AI and robotics. I think that's the holy grail. If we can work more closely together, that would be great.
Yeah. Definitely.
Thank you. Thanks, Lawrence, and thanks, Prof. Ang. All right, on to the next question. How long, this is from Manuel, and he's asking, how long does it take to train a robot on AI? given the scope and complexity of a specific application, is there any way that we can estimate the duration of such a training cycle? So I'll open this to our speakers, right? If anyone would like to address this.
Maybe I'll chip in very quickly. The time
Sure.
depends on the complexity of the problem. It can range from as simple as a few minutes, right? Yeah, or a few seconds even, right? Yeah, it depends on the complexity, or to days and months. And it also depends on the GPU hardware you have. Yes, yeah. You can, it depends on really the data. You can search the internet. There are websites from Google, for example, or teachable machines, right? That you can see how well they work, and you can also train it, right, from scratch. For example, you show it pictures of you. This is Marcelo. 5 pictures of you, 5 pictures of your friend, let's say Lawrence. This is Lawrence, and 5 pictures of Etikan, and 5 pictures of Wansin. And then after that, you say train, boom. Then in a few seconds, you test it, right? And it already works. You don't even need hardware because it's all on the cloud. So there are many such services from Google, from Azure, Microsoft. I think Lawrence would know more about all these AI tools. The nice thing today is there's so many tools for you to use. Yeah.
Thanks, Prof. Ang. So you mentioned about the complexity. So here I would like to actually throw in a question, right, to maybe our speakers, Dr. Etikan and Ken. Are you able to share with us maybe what are some of the challenges when companies actually embark on implementing AI automation projects, right? So I think here we have with us in the audience companies from mid-sized enterprises to the large MNCs, right? So what are some common challenges that you guys have seen, right, that the industry faces today? And yeah, could you share some of these experiences?
Sure. So I'll chip in some others. Then Ken can share definitely from his experience that we have, right? So I work on a bit more on I call translational research, where looking at real world problem, but there's no solution out there that available to solve a specific pain point. From that experience, what I'm going to share is I work with many companies looking at their problem, and there's no algorithm is not really available. So we need to build the algorithm. The biggest challenge is, of course, the business processes first. The CEOs, the CXOs need to be very clear what is the expectation to AI and to the project team. That must be very, set clearly. And decomposing the problem, again, must be very important so that we can be very objective to achieve a specific outcome from the project. That's most important. Given all these challenges all solved, the hardware for training and inferencing that's taken care by Nvidia is not a big deal. There is so many algorithms out there that's available. Now coming back, what is missing in the so-called the big data, right? Which is the algorithm, the compute, and the last part is data. Having a good set of data is very, very important. Depend on type of project that I look at, I work on. Clean data, which is labeled. It'll take sometimes it takes almost 80% of the effort of the team. It's not because they don't have a data. In some cases they do have the data, but then the data is not properly labeled, right? That's where we spend a lot of time to do that. Once that is done, then we can actually move on in terms of training the network. So when we see train the network, neural network in this case, for example, in the soft robot perspective, having a knowledge within the AI algorithm itself. So that is another area that I've seen some challenges are there. But of course, there's a lot of training available, a lot of references available. Can work with, for example, AI Singapore, or together with NUS, and locally in Singapore, we have a lot of trainings and then available. So having very specific skill set and knowledge on the specific algorithm within the vertical, it's next area, which is very important. After all this happens, we can get a POC done. but with a POC translating into a commercial ready, or I call production ready environment. That's where you need to work with bigger ecosystem partners, the SIs, all of them has to come together so that you can have production ready running solutions. That's from my activity that I've done, projects that I worked on. Ken, maybe you can share your experience, Ken.
Right. Yeah, thanks, Dr. Atikan. From our perspective, what we see is that we got to work closely. For example, when we work with the manufacturing sectors, we got to work very close with the executive to share the pinpoint and define the problem statements. And then, and from there, because the solutions that we are looking at, it involve data preparations, it inform AI skill sets and all that. There's also need to very much depends on the tap on the ecosystem to make the whole solution works. So the other part will be in the area of skill sets and all that to be developed as well. And the final part will be funding, but I think we spoke about that earlier, that you can go to Enterprise SG. And I think last week I also read about SGTech, right? Started a fund for digitization. And I think that's a good start. Maybe those you can start with small projects, yeah, to get it started.
Right. Thank you so much, Dr. Atikan and Ken. Right, and I think thanks to Lawrence as well, who has helped us address some of the questions that came through the Q&A. So with that, again, yeah, conscious of the time, right? So I think we would want to wrap up the session here, right? And if there's other questions that the audience have, you are most welcome to stay on, right? To interact with our speakers who will still be here for a little while more, right? Okay. So thank you all again. And before we go, just want to call out to all complete these post-webinar feedback. Right? All you need to do is just to scan the QR code and to access the survey. So all responses will be kept confidential.
Thank you all. I'm sorry I have to disconnect. I have another conference call at 2 o'clock. Yeah.
Sure.
Okay.
Thanks,
It was nice
Pop,
doing this. Nice to give this.
Thank you to all our speakers. Yeah.
Okay. Bye-bye.
I'll just leave this on for a bit for our audience here, right, to assess. But meanwhile, if you have questions, again, keep them coming through the Q&A, and our speakers would need to trouble you to answer them directly.
This is Lawrence. I saw there's a question on any successful story implementation of AI in the local pharma industry. We did work with one, but it wasn't in the manufacturing side. It was actually more in the operation side. Very standard customer segmentation to figure out what key customers and what to sell to them and so on and so forth. So it's more a traditional data science, data analytics sort of work. Not so much in the manufacturing shop floor. For manufacturing shop floor, we have worked on quite a number actually. Yeah.
Okay, so thank you everyone again for your time this afternoon. All right, thank you for joining us. We would also send along some follow-up materials, right, post-webinar. Hope to see everyone at the next SGTech engagement. Thank you and have a great afternoon.
Thank you.
Thank you, everyone. Bye.
Thank you.
Thank you.